Good afternoon and welcome to Rakia Mission Scientific Conference and welcome. 12 years ago, the whole world was talking about the end of the space age. No one dreamed that 2 years later, and SpaceX would open a new era, an era in which barriers were broken and new dreams began to take shape. 10 months ago, another barrier was broken. For the first time, a group of civilian pioneers underwent full astronaut training, donned spacesuits, and embarked on an unparalleled journey to carry out missions that would affect the lives of many people. The impact of this mission, AX-1, heralds the beginning of a new phase in the new space era, a new model where even countries that do not have their own space programs, organizations, and individuals can take part in the great journey to space. It is a milestone in commercial human spaceflight and demonstrates a new approach to making space travel more diverse. It also provides a compelling model for how space travel in the 21st century can be done, whom it is for, and what outcomes it can achieve. Rakia mission was crafted under the vision of Space for All. When we set off, we called everyone to join us, and you did. We received hundreds of ideas, teaching activities, artwork initiatives, research, suggestions, and public engagement campaigns. This unique approach of an open source mission is what made this mission so successful. We all share the excitement at the takeoff here in Tel Aviv and also in Houston and Florida and in the homes of the rest of the crew in US, Spain, and Canada. Israeli teams accompany the mission every step of the way. A special visitor center connected the younger generation to the mission. Every video call we received, we were excited. Every result of an experiment sent to Earth was a celebration, and there were many celebrations. The outcomes of this mission were even greater. Just a few examples: 322 scientific researchers participated, over 165,000 students, 80 artists, and overall we made 95 distinct contributions across 10 of the UN SDG, which is UN Sustainable Development Goals, with an emphasis on climate action, good health, well-being, and quality education. Today, we conclude the record-breaking Israeli experiment that were conducted experiments that were conducted on board International Space Station during this historic mission. Many people were involved in this amazing achievement, but it all began with a dream, and I would like to invite the dreamer, AX-1 mission specialist, Eitan Stiba.
Thanks, Sharon, and thank you all for being here, because it's you who made Rakia possible. And without you, this dream of bringing along everyone, children, adults, matching education and science, and bringing all that to the Israeli public was not possible. So really, thank you. And special thanks to my crew, Mike, Larry, Mark, and their families who supported each other, gave a shoulder when necessary, and really made this amazing mission possible, and we realized it all. The Ramon Foundation, who supported from day one all the way through, and the Rakia team, who really allowed me to train as an astronaut and in parallel prepare the whole mission and its content. And it didn't finish with the mission, because the mission, we landed safely, happily, and the mission continues. Because the idea is to continue in the attachment of Israeli activities in all sectors with space. So that's the mission we put in front of us. This is a cooperation we're creating with Axiom. Hopefully the next future modern space station will be up there very soon. So that's our mission, and you can help. And like I heard during the cocktail reception, that scientists did not even think it is possible to send anything to space, so it is possible. And the people who can achieve that are here. We have people from NASA, from Axiom, who can solve your problems. Just dream and it will become true. Have a pleasant evening.
Thank you, Eitan. The Space Agency recognized the potential in a manned space mission, the first Israeli astronaut on the space station, and together, in a fruitful collaboration, we set off. This is a great opportunity to thank the Space Agency and the Ministry of Science and Technology for their contribution. Please welcome Uri Oron, CEO of the Space Agency.
Thank you, Sharon, and thanks for the guy who decided to put a big screen. Just imagine you need to decide whether to look at me or to look at the sunset towards the sea. I know what I would decided, so big screen, it's a good, very good answer. Anyway, I want to start with a few thanks. Thank you to the people of Rakia for the invitation and the opportunity to be here and have a couple of minutes to speak with you, and especially to Meirav and Melody. Where's Melody? Somewhere here. But again, to one person that without him, all this wouldn't be possible. So it's to you, Eitan. Thanks very much for the vision and for the determination to do that, because we know and you know it was not simple. The reality of our life is changing all the time, and those changes are happening today faster than ever before. Let's take a look at this event, for example, where we are going to discuss the scientific aspects of a space mission. This discussion, and in fact the entire mission, was led, founded, and operated privately, as mentioned. Such discussion was not possible a decade ago, and in fact, it was not possible even a year ago, simply because this is the first private mission. And again, not just countries, not just big research institutions, not just government organizations. Space is open and more accessible to everyone. Entrepreneurs, scientists, educators, artists. It means new opportunities. And this is very, very, very welcome and world-deserved change, and I'm saying that as a government entity. We need those private entities to go inside the space world in order to change it. Otherwise, it probably would have been stayed on the same place. So that's a very, very good opportunity. Now, the state of Israel sees the change and understand it. And you will discuss later on the Israeli opportunity in space here in a few moments. Rakia mission, in which the Space Agency took part, demonstrated in a wonderful way the value of making space accessible to the mass of activities. The Rakia mission taught us that the possibilities of promoting a variety of issues through activities on board the space station is possible and within reach and even simple. That's why it is so important to me to say that in the light of the insights of the Rakia mission, the Israel Space Agency will continue to promote access to space for all kinds of activities: tech R&D, scientific experiments, education, and other activities. We will do this in cooperation with others, and we will do it as fast as we can. Again, thank you, the Rakia people. Thank you, Michael, Larry, Mark, and again, Eitan, for taking one small step in the right direction. Unfortunately, I have to leave to other obligations. You know, it's a Space Week, and we are very busy. But I will meet you all on Tuesday and probably tomorrow night at the conference and during the rest of the Space Week. Have a great evening and a great event. Thanks very much.
Thanks, the Space Agency. The previous CEO is here, and the present CEO and the chairman are all here, and for your support. And it was all along through education, science, everything. Thank you for everything. So usually when you launch an event, you see the launch of a spaceship. I want to show you the excitement and the feeling that we had when we started a few hours before the launch.
What a vibe. The goal of the Rakia scientific mission was to promote international collaboration in the Israeli space ecosystem while focusing on multidisciplinary research. This week will mark 20 years since the STS-107 Columbia disaster and the loss of the crew. Among them was the Israeli Eitan's friend Ilan Ramon. The first experiment we'll hear about today is a continuation of the imaging of thunderstorms from space that was conducted by the Columbia mission. The Ilan ES experiment attempted to capture the unique electrical effects that occur above storm clouds for the first time with high-quality cameras. This phenomenon, known as the transient luminous events, TLEs, can take various forms, including blue jets, sprites, and elves. This experiment was unique for involving dozens of schools and hundreds of children working to support the mission as ground observers. This project also represents one of Rakia's mission main goals to explore various aspects related to our planet's climate crisis and raise awareness to the importance of Earth observations. I'm honored to invite Professor Yoav Yair, Dean of the School of Sustainability at Reichman University, to present the results of the Ilan ES experiment. Please.
Hello, everyone. So 7 minutes to try and describe a work that conducted by the team. I don't see the presentation somehow. Okay, there you are. So I'll try and briefly take you through and some refresher, because some of you probably do not know what sprites and elves and what are those mysterious lights are. Let me first say thanks to the entire Ilan ES team, students from Reichman University, colleagues from Tel Aviv University, and others. So you see a lot of players from Stanford, from Brazil Space Agency, INPI. It was a big team because it was a global experiment. What we aimed to achieve was actually look at thunderstorms at night, something that most people on the ISS don't do, and only few satellites ever do, and with a high efficiency of time, the time of astronauts, which was a gift to me as a scientist. It's very valuable and we really appreciate it. Try to conduct multi-station from the ground and space, as was mentioned, and try to get, whatever you can. And I can show you that even 20 seconds of high quality video from space can bring new science. So just a refresher, this is I would say, let's see if the video runs. Can you make the video on the right? Okay, take a look. Did you see that? Okay, that's a sprite. Now in slow motion, you will see how beautiful it is. There's a huge zoo of optical phenomena above thunderstorms, and they appear as jellyfish, giant, 40 by 50 kilometers large. And we are trying to locate those animals. So here we go. We went into space. Eitan and the crew had a unique asset, never flown before to the ISS, and I can share with you some of the images we tried. So in order to know what time the astronaut has to go to the cupola window and point the camera, we need to know where lightning will be a day and a half in advance. And we have developed and actually perfected a way to do it by anticipating where the ISS will be, what is the line of sight. Those circles show us where the horizon is, which means what is the view that you can actually observe from the ISS, and where lightning will be. And we know how to do it since 2003 for the MADEX experiment. We developed, and it was already tested 2 other times with Japanese and Scandinavian astronauts. So Eitan was the 4th to experience this method. We beamed up every day a list of targets through Melody sitting at X1 mission control, and we had a wonderful camera on board the D6. Now, I want to make it short so you can enjoy the images and tell you a little bit about the science we already have. So we had 84 requests beamed up to the station, and we got lucky to get 22 done. And the total video that I have is almost 155 minutes, which is a treasure trove. I confess, I never expected to get that much, and it's really, really great. So from a first survey, we got 46 TLEs. Some are, I will show you, 10 sprites, halo, elves, blues, which are unique and new, 4 meteors. I think we reached above 80% in lightning accuracy, so that when the astronaut reached the copula at the right time, he knew where to look. So let me share with you some images. Sprites appear as red dots, just 1 frame out of 60 per second. You don't see them with your eyes. You only post-flight can see them. And I'm not sure you guys can see, but there are some sprites over the horizon. By the way, this is a very rare image, a sprite at sunset. That's very hard to achieve. On the Earth, it's almost impossible to get such images, only from space. So I want to share with you one specific event. We knew there was going to be a big storm right off the coast of Australia, near French Caledonia, and we gave a request for imaging. So this is post-flight analysis. The dots that you see are actually where lightning was. This is the satellite map, and you can see the red dots are actually where lightning was. And we even were able to identify the parent lightning for the sprite you will see now. Now, this is the best ever sprite image from space. When I showed it in Chicago just a few weeks ago at the American Geophysical Union meeting, my colleagues came to me and said, Yoav, this is Photoshop. That can be that good. They could not believe. And you can see how the sprite is located above the lightning, bright red. This is excited nitrogen molecules emitting in 665 nanometers. So this is fantastic. I mean, I would have been satisfied with this, Eitan. Just this image, brilliant. And you can see, by the way, the sunset west of Australia as we were flying above those huge cumulonimbus clouds. And then we got a bunch of elves, those beautiful donut-shaped, really huge lightning-related discharge above the thunderstorm. And you can see how magnificent and huge they are. And the best one yet is this one. And Melody was the one who found it post-flight on the video. So these are huge phenomena, mysteriously appearing and disappearing before our eyes. And these are some blue events. We could have seen them very clearly in the images post-flight. I want to share with you one specific event which shows you the high value of even 12 seconds of video data from space. So we were flying, you were flying, guys, above the Andaman Sea between Bengal, Bay of Bengal. We knew there's going to be a storm there. There you are. You can see the lightning superimposed on the clouds. And take a look. Let the video run. Okay, so this is nadir view. Did you see the blue dots? Okay, these are very rare. And you will see sunrise already coming. So these are the last 12 seconds before sunrise. And you can see the thunderstorms. Maybe you've been quick enough to see the blue dots. And there is sunrise. So it's all over. But in that less than half a minute, we could have seen those types of discharges. Really a new class of TLEs, blue events on the top of the cloud, not high up in the mesosphere, 50 or 80 kilometers above. This is occurring right at the top of the anvil, and we don't know exactly what the mechanism is. A big research is going on. And my colleagues said they could not believe the quality of the images. So we tried something that was never tried before, and this is a conjugate event, which means you have thunderstorm in one side of the Earth, and it emits high-energy particles guided by the magnetic field that impinge on the upper atmosphere on the opposite hemisphere. We had been very lucky to have storms in the US right when the ISS was flying above the South Pacific, which is the conjugate point. So we asked Eitan to take a look on a target where there was no lightning, but we were hoping that something will reach from the upper atmosphere on the other side. So this was the prediction. This was on the left, the prediction. This is how accurate the prediction was. Actually, there were storms in Alabama that night. And this is the values of the intensity of lightning. And we were hopefully, imaging the Earth, but we only saw clouds. We saw no such event. However, we put a research proposal to the Israeli Science Foundation, trying to repeat this, not from space, from the ground, putting cameras on Mount Hermon and Itzpe Ramon, and looking at the sky above Israel for conjugate events from storms that occur in South Africa. So from the video, not only TLEs, but lightning, there's a research going on now with my colleague Lior Bernenko, now in Technion, formerly in Stanford, here in the audience, and we will be looking at a phenomena that I'm sure astronauts have seen, lightning occurring in what appears to be synchronicity. That was actually observed on STS-1, on the first mission of Space Shuttle Columbia in 1981. And we've published a few papers on that, and now we're going to harness machine learning and AI to look for synchronicity and maybe decipher what's going on. So we had a ground campaign, as was mentioned, 11 schools in Israel, an additional 9 in Africa, Asia, Brazil. These are the only 2 sprites that were imaged from Israel, from the ground, from a school in Faradis, an Arab-Israeli school with children. Looking every night when we flew above. We had many students in Africa doing that. We didn't get any sprites or lightning from Africa, but the cameras are still there, and we are still in contact with our colleagues. So let me summarize and say we've received much more than we hoped for, and thank you for giving us the opportunity to once again observe the beauty of the planet as it is manifested by those transient luminous events. And let me just finish with this. 20 years ago, this week, on the left, the image from the MADEX experiment by Ilan Ramon, and this is by Eitan. So a closure. Thank you very much.
Yoav, stay with me. Thank you. For a few more minutes, we want to ask the X1 crew about their experience. Mark, I understand you spent some time at the Copula window, and we would like to hear from you. What do you think about the platform, the ISS platform, for research of climate crisis and outreach?
Yeah, thank you. You know, these days, of course, we have very sophisticated satellites that are constantly orbiting Earth and taking photographs and imagery of the Earth. And so one might ask, well, what is the actual added value of a human taking pictures of the Earth outside of the cupola window? Can't we just observe everything and learn everything we need to know from the images of satellites? And certainly we can get a lot of information from there, a lot of data. But I think that there's an added value to human photography from the cupola of the space station in 2 ways. One, I would say, is the images themselves, and of course satellites take very good images, and you can direct them to take very specific images and compare them over time and look at how the landscape is changing and how ice formations or whatever it is you're studying are changing. But the view from the cupola, as you're zooming around the Earth at 28,000 kilometers per hour, it is dynamic and it is changing. The Earth is alive and it is constantly changing. And so the different perspectives that you can get with human judgment in terms of the pictures you take, the angles you take, the zoom, the things you include in the images, the perspective and context that you add through that extra human judgment, I think, is very interesting and can be very important. The other thing I would say is, from an educational standpoint, if I think back to what teachers were most influential to me, what people had the most impact on me in my learning and my developmental years, it wasn't people who were just able to transmit data to me in the most efficient manner. It was people who were able to speak to me with passion and with emotion and with perspective that made me take note and take interest and think. And that only comes from a human. A satellite cannot provide that. So to me, when I take, for example, the pictures that I took from the cupola, from space, whether they were just my personal pictures or there were ones that were specific targets that I was assigned to capture for specific research projects. I can, having taken that picture and then presenting it, I can add so much context and perspective that just does not come simply from a satellite image. So I think that really continued human photographic data from the space station is going to continue to be very important, not just in terms of showing us what might be happening to different places on Earth as we experience climate change, but in communicating in an engaging and impactful way what we're seeing and what we're experiencing. And that, to me, is what's really important in creating change.
Thank you, Mark. And thank you, Yoav, for your enthusiasm.
Sure.
I'm thinking about your students, how lucky they are. Yes, and I think I speak on behalf of this audience that we would like this experiment to continue. Lowering the barriers in space travel is one of the most important challenges the space community is facing. Another barrier is choosing what to wear. A daily challenge for most of us and a multi-million problem for the space industry. We're not talking about fashion, of course. Astronauts can take only like 3 shirts and 2 pairs of pants, right? So we're not talking about that. We're talking about space environment protection. AstroRad is an anti-radiation protective suit based on selective protection that has been developed to protect the astronauts on their way to the Moon and Mars. In prolonged missions, radiation in these areas might damage their function, and in the long run, they might even be fatal. Eitan Steve wore the AstroRad during his time on board the ISS, but I think we're all interested in hearing about the AstroRad and the Moon. The suit was part of an experiment on Artemis 1 mission to the Moon that came back to Earth just over a month ago. Today, we'll be the first to hear the conclusions of the Artemis 1 experiment. Please welcome Dr. Oren Milstein, CEO of STEMRAD. Please.
Thank you, Sharon. Thank you for having me here. It's a great pleasure. It's a very exciting period for STEMRAD and for the Israeli space industry in general. I was very proud that Steve agreed to participate in our experiment, and his contribution was very, very important, as I'm about to show you. So if you could move on to the next slide here. Actually, that's my job. Okay. Okay, so AstroRad is wearable radiation protection, and the purpose would be to use this when the crew members are going to venture into deep space, first of all within the confines of the Artemis program, but in the future, hopefully also private industry will take people to the moon and beyond. In those areas, as the speaker before me underlined, you can be exposed to 2 types of radiation. It could be radiation from the sun, solar particle events, or galactic cosmic rays. Now, if you're venturing for a month or 2, your chief area of concern is actually solar particle events, because they can really, when they come in violently, they can max out your career dose within 1 event. So you won't be able to fly again. When it comes to galactic cosmic rays, to receive a considerable dose, you would have to be there for the mission to Mars. Something of that nature. So the short-term or mid-term missions, you're less concerned about that. So STEMRAD chose to address first and foremost the threat of radiation emanating from the sun in the form of solar particle events. And for that, we made the AstroRad vest. Now, solar particle events, they can last anywhere between a few hours to a few weeks. So being in space for so long during an event requires a solution that allows the crew member to continue to perform his vital functions while trying to remain protected. One solution is a storm shelter inside Orion. And the shelter is something quite protective, however, very confining and very limiting of the ability to move around. So we came in together with Lockheed Martin. We developed this solution to allow crew members to venture outside of the confined area and do their job while they're enjoying the valuable days in deep space. So our innovation here, as was mentioned in the introduction, was selective shielding of the most vital organs within the torso region. Protecting the whole body of the crew member is quite impossible, so we chose to protect what really counts, and in doing so, diminishing significantly the likelihood of cancer down the road, or God forbid, acute effects within a very short amount of time. So here you can see on the right, you can see astronaut Jessica Watkins wearing the vest. She was our last crew member to wear the vest. This was broadcasted during the Artemis launch, so you can see the countdown and the clock on the left. And it was very exciting to see this together with my kids. This vest was a few months before worn by Eitan, and I'm going to show you a picture of that as well. Because the events can last up to a few weeks, the issue of ergonomics and comfort is really critical. It's not enough to protect. You also have to protect in a way that the crew member wants to be protected. So to analyze the ergonomics, we basically worked with 5 crew members, 4 females and 1 male, to try to determine any kind of bottlenecks with regards to the ability to move during general operations, which included housekeeping, cargo, unpacking, sleeping, eating lunch, just hanging around the crew quarters, and other more complicated things. And we found significant, but significant, meaningful limitations that we're able to overcome through quite simple improvements in ergonomics. Our way to enumerate this was to implement computer vision, to take the 2-dimensional video that we see here and turn it into a 3-dimensional figure. So we're able to accurately quantify the different limitations to movement that crew members experience throughout the duration of wearing it. So we have tens of hours, hundreds maybe of video of crew members wearing it. Here you can see Eitan wearing the vest, and I had a 1-hour conversation with Eitan. It was right before Passover kicked in, and it was a very nice conversation, I think maybe one of the first in Hebrew with the International Space Station. And we were able to work through the different issues. Immediately became apparent that there's an issue of cross-gender suitability. Indeed, the vest that we sent up was meant for the female crew member, given that females are more susceptible to radiation. So it's basically built on the inside in a way that accommodates the specific sensitivity of females. So Eitan experienced some limitations that were unwarranted for a male, that would not exist naturally for a male version. And he basically pointed to those differences and basically confirmed our feeling that having a single product for both genders will not work well. So the key findings was that you're able to perform almost all of your day-to-day functions on station, but with limitations. And these limitations can be easily removed through basically redistribution of some of the shielding from, for example, the frontal area to the back area. We found very little limitations associated with the posterior part of the vest. So moving, shifting distribution, and also increasing the gaps of the openings, arm openings and neck opening. And so those are the key findings. And then with regards to sizing, we found that it would be ideal, because even within the females that wore the vest, there were some 6-foot females and 5'4" females. So we found that some level of modularity is necessary within the vest. So the plan is to have one product per gender, but that product is modular by the addition and distraction of certain modules to the vest. Basically 2 modules, one to increase the length and one to increase the circumference of the vest. And now we're working on implementing those conclusions. And Eitan served a very important part in confirming something that we've been saying, and not always receptive to what we were saying. If you look at the EVA suits, They're basically a single gender solutions, but women have been complaining for many years about the need to address their specific anatomy. And we're seeing this from the reverse angle today, and we understand that not only biologically it's justified to have a gender-specific solution, but also ergonomically. And the ergonomics are critical for our product to be worn for 2 weeks. So definitely a very profound insight gleaned on ISS. And then regarding Artemis, I don't have too much time left, and actually the results are not yet ready for publication. So obviously this is going to be a peer-reviewed publication that is going to be published hopefully in a very lucrative journal. But I can tell you that we just came back from Kennedy Space Center. We were there for 10 days. We unpacked Helga and Zohar, who flew around the moon on board Orion. Here you can see them basically seated in the crew seats 3 and 4 of the Orion capsule on the launch pad. And they spent, I think, 21 days in deep space. And they came back with a treasure trove of information. I can tell you that all the detectors, all the 6,000 detectors involved worked. Okay, so for 10 days, they were reading out the data. And now in Germany, in Cologne, they're analyzing this data. And we'll have a very profound understanding of the efficacy of the vest, of the benefit that it provides for the health, in this case, of the female. The mannequin wearing the vest was Zohar, a female mannequin that simulates the human body really one-to-one. So that's it. That's all I have for you today. I hope to have more results in the near future. Yeah. Okay.
Stay
Okay.
for a few
Yeah.
more minutes.
Okay.
You can stay. Let's turn back to the crew and ask Mike, given your extensive experience in space travel, I understand it was your 5th journey, your 5th mission. Could you tell us the importance of radiation protection?
Of course. Thank you, Shalom. And congratulations on the experiment. So to put things in a bigger context, one of the reasons that we are doing a lot of research in low Earth orbit is still to study the effects on the human body of deeper space exploration. So as is obvious now with the Artemis program, NASA and the other agencies have set their sights on going back to the moon and I think someday onto Mars. And so what we are learning in low Earth orbit can help us in developing countermeasures. So as an example, not related to radiation, I flew my last mission about 15 years ago. And when I came back after about 7 months in space, I had lost an average of 12% of my bone mass density, which is quite a lot, but average for the time. Now, due to the countermeasures that have been developed, people are coming back with sometimes no bone loss and usually within 1 or 2% of what they had pre-flight. So this is an example of a box that we have to check in order to mitigate all the risks of going into deep space exploration. And of course, radiation is another very important one. So even though we're talking about solar radiation here and not GCR, galactic cosmic radiation, which is more significant if you're going onto Mars, today's propulsion would allow us to get to Mars in about 6 to 8 months there, another 6 to 8 months to get back, and based on how the planets align, about 6 months there. So you're talking almost 2 years of a mission. Today, the maximum a person could spend even in low Earth orbit with the current radiation protection is probably about 2 years, again, depending on your gender and your age, et cetera. And that's with a fair amount of shielding already on the ISS, and you're protected by the Van Allen belts and sort of the comfort embrace of Earth. So going on to Mars, of course, is going to need some kind of much bigger additional mitigation of the radiation risk, and I think this is a very positive step in that direction. Thanks.
Thank you. Thank you, Mike. And thank you, Dr. Nelson. Thank you very much. Sometimes it seems that we need to travel the farthest to be able to connect better with each other. One of the main areas that interest commercial companies in the space sector is the field of communication. But what do you do when an antenna you send to space doesn't work? You can't just pull it back down and test it. In situations like this, it's good to have an orbiting lab like the International Space Station where you can test your nanosatellite antenna. Please welcome Daniel Rockberger, co-founder and chief engineer, and Ido Dagan, head of the mechanical department of NSL Com. Please.
Can't see anyone. Thanks, Sharon. Thank you very much. I think it's quite amazing after everything we did before that we're all sitting here after the mission talking about our experiments and with the crew safely here. So it's quite amazing. So just a few minutes of our experiment. As you can see here, we are a company developing communication systems for small satellites. And one of the main things of our system is not only we do the electronics, but also the antenna. And we're turning a very small satellite into a mean machine of communications. And the deployable antenna is one of the main factors there. We've developed a flexible material antenna that does not work on Earth in 1G. It's made for space, it's lightweight, it's floppy and flexible, and only under zero gravity conditions can it take its perfect shape. This antenna has to be very accurate, less than 0.5 millimeter in accuracy because of the frequency, which is the thickness of a piece of paper, and it will only take its shape in 0G. So to test it on Earth is very difficult. We have to take it to 0G in order to know what is the real shape of the antenna before we put it on a satellite. So we always like to have fun when we work, don't we, Dor? So we've done 0G flights in Canada, persuaded our founders, other co-founders and our board, we have to do a 0G flight to test the antenna. There's no other way to do it. So we've done many 0G flights and had a lot of fun and tested the antenna. However, it's only 22 seconds each time. An antenna obviously lives for a few years in space, and it's not enough time to see it stop its oscillation, to have it stable. The materials also, after it's been folded for a few months, take a few days even to stretch out to their lovely shape, and you can't test that in 22 seconds at a time. So we had to have some zero gravity for a longer duration, and that, of course, was the opportunity for the Rakia mission. I can also add that this was not an easy project to persuade my company to do. We were just finishing the last few months of our satellite. It did cost some money. Is it the best time? Will we have the results in time before the launch? I remember going to II for the PDR. I was the only, nobody knew I went. There was still no project in the company, but I still went. And of course, slowly the company understood how valuable it was. So the experiment obviously was to send, we made 3 antennas. This was really a few months before the launch of our satellite, or 6 months. We made 3 identical antennas. One was for launch to space, one was for spare, and one was for Eitan to take. I think our antenna went up with the crew. And of course, the idea was to deploy it on the station, but also take imagery and pictures of it and reduce the shape, which Idor will explain in a minute, how we reduce the shape of the antenna just by taking pictures. Can you show the video? Just a second before the video. You go back. So you can see the nice little shiny dots on the antenna. That's part of the secret and the clue of how we take the shape. But we'll get back to that in a minute. Video, please. So this is the antenna when it's folded. It's an origami 60-page procedure onto folding the antenna. It's in the size of the palm of your hand, like a 1U volume. That's Eitan's hand and watch, you can see, of course. I think all the astronauts and all the cosmonauts came to see this event. And you can see how it deploys into a 60-centimeter dish, which is quite big for a small satellite. And after about 12 seconds, I think, it completely stops wobbling, and that's its shape. So we were completely surprised how successful this test was. We did not know if it's going to work, what's going to happen. The deployment, as you can see, was perfect, and also the shape was perfect. So Idor will explain now about how we determined the results.
Hi, everyone. My name is Idor Dagan, and I'm in charge of the mechanical department at NSLCom. I actually met Eitan 2 months before the launch date in Houston for practicing and for training for this mission. And I want to thank Eitan, Larry, and the whole team for such an amazing experiment that had a great impact and that done a lot of things good to our company for the last few months. So first of all, you just saw the video of the deployment, which Daniel explained, was very successful. The deployment of the antenna was very smooth. It deployed to its final position after less than a second and a half and stabilized in less than 20 seconds as desired, and we are very happy for that. The next step was we asked Eitan to take a lot of pictures, mostly 120 pictures in the ISS in different location and different orientation. What? Yeah, but for the first day, just after the deployment, we asked for 120 pictures taken from different locations. You can see over there Larry taking picture of the reflector. And I know it wasn't so easy to perform because you need to stabilize yourself, your body, as well as stabilizing the camera and pushing the bottom as well at this time. As you can see in the picture here on the right, you can actually see the placements of the camera whenever you took or push the button to take the pictures. Then we can calibrate the photogrammetry model and perform a full or get a full 3D model out of this surface antenna. The antenna is in green, of course, like Daniel showed before, the targets on top or upon the antenna. And from that, we just got a 3D model that continued to another RF analysis in another software with our RF engineer to compare this reflector over a reference mathematical reflector and to compare between the two and to understand how accurate the antenna is in microgravity environment. And the results were very, very good. We got very small degradation in relation to the mathematical surface. We got like less than half a dB degradation, which is very negligible in terms of RF results. We also had, after 2 months of folding of the reflector and the deployment of it, we got a TRL, which is a technology readiness level of TRL 9, basically, that it accomplished and worked in a microgravity environment and went through all the launch campaign of Falcon 9 rocket, including vibrations, including acceleration, etc. So it gave us a great confidence that this material and this product is going to work in our next mission. And I'm happy to share that we launched our second satellite about 3.5 weeks ago with Falcon 9's SpaceX rocket, and it's orbiting now around Earth with the same design of main reflector antenna, and we are very, very happy about it. And the presentation states here that the success of the experiment was crucial for the future of the company. We felt it all together, so thank you very much about it.
We have something for Larry and for Eitan.
Nice. You've mentioned the cooperation between the crew. Ken, you can ask Larry to come. Yes, we have a question for you also, Larry. Yes. And we have a question for you. How is it for you, Larry? You're the pilot of the X1, and how is it for you, apart from your day job, let's say, apart from your job description, you had to take pictures of the antenna every day and cooperating with these guys?
Sure, I would have two comments. First, personally, as I was taking those, depending upon what time, 90 to 120 plus, sometimes literally on my head, trying to brace, I thought, oh, I hope this works out. And so apparently it did. So thanks to both of you and your company. In terms of the bigger question of cooperation and volunteering for other experiments, I really think that's the essence of the AX1 mission. That there were 4 people from literally around the world who came together, civilians, and who trained for many, many months And there were some people who were skeptical about, could we really do this? We were the first. So we knew we had a responsibility and we had to get it right. Also, too, there were some who questioned the value of the research that we took into space. And I think based upon the results, not only here, but the wide multitude of all the experiments we did, we answered that question, and that civilians can, and the private sector can, make a valuable contribution to space. Thank you.
Thank you, Larry. Larry O'Connor, and thank you, Daniel Rothberger and Ido Dagan. Imagine the following situation. You go into the optometrist, choose a frame for your glasses, and leave there 15 minutes later with a new pair of glasses with lenses you've just been manufactured that fit you perfectly. Now imagine the same process with a massive lens of a space telescope. The next experiment is part of the revolutionary project called FLUTE that can really create a huge change in the world. Let's welcome Professor Moran Berkovich from Technion Israel Institute of Technology, who will tell us about the project.
Thanks very much, Sharon. Thanks for the introduction. Thanks for having me here today. Well, this picture, this is a rendering. This is not from the actual experiment. This is a beautiful rendering that Rakia made before the mission, but it tells the story. This is Eitan injecting liquid in space to use surface tension to create optics, to create lenses in space. So this is the rendering, and now let's see how well Eitan did. So I think the James Webb Space Telescope does not require any introduction. This is really one of the greatest human creations, launched just a little over a year ago, and already providing amazing pictures of space. This is not a rendering. This is actually one of the experiments. If you're not following the images from James Webb, do that. And James Webb, like I said, is an amazing creation. Let scientists look further, deeper to the past. But we, as humanity and astronomers, as our representatives in science in this field, have much bigger dreams. For example, being able to image exoplanets, planets outside the solar system. And to give you some perspective, this is the Hubble Space Telescope. It is 2.4 meters in diameter. The James Webb Space Telescope is 6.5 meters in diameter. And if we want to image exoplanets, the estimates, it depends who you ask, but we need much larger telescopes. How much bigger? About 100 meters. Now, there are no current technologies that can create a mirror of 100 meters. And even if we were able to create one, there's no technology that can take a mirror of 100 meters and bring it to space. And this is where we come in with really a fantasy. This is a collaboration between my lab at the Technion and our colleagues at NASA, my good friend and colleague, Dr. Edward Balaban, and the amazing team that he put together there. The fantasy is, let's not create the lens on Earth. Let's bring to space liquid and deploy it to create the optics directly there. This is a rendering of how we imagine this to be. It's always fun to see the Technion logo next to NASA on the rocket there. But this is a much longer story and made it shorter here, but there are going to be 2 launches and going to rendezvous in space and so on. But ultimately, there's going to be a frame that is going to open up in space. That frame is pretty still significant, has to be large enough to contain the liquid, but it does not have to have optical accuracy. The optic comes in through the liquid, which through surface tension will cover the frame and give us the required optical properties. So the first step to test this, similar to my colleagues in the previous presentation, is to go to parabolic flights. And one great reason to do parabolic flights is because it is fun. This is us in our last parabolic flights. Just a couple of months ago, we did one a little over a year ago before the AX-1 mission. We can compete with the AX1 heroic photos, but that's our attempt here. And this is what the experiments looked like. This was about 4 or 5 months before the AX1 mission. I hope the sound works. It's part of the fun here. What you're going to see the G on the top left, and you're going to see liquid injected into a frame creating a liquid lens. So here we go. Maybe a little louder. There, thank you. There, we're pulling this plug. Light is being injected, light, camera, action. Liquid is being injected into the frame.
We have an image!
We were very excited. This is Omer.
Yeah!
So what's happening? We have an image, means we're imaging through the lens in real time, and now look at the gravity, look at G is coming back, and it oozes back down. So we proved that we can create a liquid lens in microgravity, but this is only about 15 to 20 seconds on a good day of microgravity. We can't polymerize the lens at such a short time, and also you see it's still a little shaky. We had dreams about taking this to space one day. We were talking about in 2 or 3 years maybe we'll be able to bring this up, and then Eitan comes along, Rakia, AX1 mission, and suddenly it became, okay, in 6 months you have to deliver everything for the SPX-24 launch. I'll just take you directly to space, to the experiment. This is the box that we created for Eitan, and there's going to be some background music. I'll narrate over it as we go along. So if you look at the bottom video, you're seeing a side view of Eitan injecting a liquid polymer into a frame. So it's just a freestanding frame in air. And some more, and then retracting the syringe again, and there we go. We have a liquid lens in space. This is much more stable than the parabolic flight. What it is doing now is removing bubbles. Everything was manual, and it was very meticulous. He removed each and every bubble that he encountered. Box contains UV light from both sides with some diffusers, actually parchment paper in between to make it uniform. The polymerization is a few minutes. Here it's sped up, and once the polymerization is done, he opens the box, and now listen to the sound.
Congratulations for a nearly perfect lens.
Oh, that is the best news ever.
And that's the iconic voice of Chrissy there. So this was very exciting. This is the first time ever that optics is created in space. Right? And now if you move your eyes from the bottom view, from the side view on the bottom to the over-the-shoulder camera at the top, you'll see Eitan removing the lens,
yes, it is.
Examining it.
Very nice.
Do you see any craters or any of that surface deformation?
No, I don't.
That looks lovely. Now we are ready to put that one in the container, and we're going to move on to the next one that you have in your hand.
This is another view of the same experiment, which I don't know if, Eitan, if you got a chance to see this. Some people here saw it. So we see a lot of what happened on the International Space Station. I want to show you what happened on the ground at the same time. We really weren't sure if this will work. You see here next to me, you see Omer, who really should get the credit on pushing all of this to success. And Mo, who's in charge of everything that has to do with liquid lenses. I'll show you some of his work in a couple of slides. And we weren't sure if this is going to work. The critical part was turning on the light and whether the UV light will actually turn on. So this is how we felt on the ground. Look at Eliran at the back.
Uh-oh.
Uh-oh. He turned on the light. I couldn't see anything. Look at our faces. לבדוק את הסוויץ'. Check the switch, we're starting to debug things. I heard something over the comms now. Are working or not working?
Yes,
Everyone got it first?
yes.
This was nerve-wracking, and this is the rest of the team back in the beautiful control room here at Checkpoint. And this is Eitan smiling to the very first lens fabricated in space. Now, an important part in this experiment is that it proves not only that we can create optics in space, but we can create lenses in low-resource settings. One reason to create lenses in space is actually degradation in vision of astronauts who often come back with several diopters change after spending time in the ISS. We're thinking of long-term missions to Mars. This is something that has to be solved, for example, creating corrective eyewear on the ISS. But another place is low resource settings is places like Africa and Southeastern Asia, where access to eyewear is actually very challenging. What we're doing currently in the lab, you see here a prototype of a lens maker that was able to create the first eyeglasses that you see on the right here on Valery Frumkin. He used to be a postdoc in the lab who started this project. And this removes the necessity for all the heavy machinery, grinding, and polishing that is currently required for creating lenses. Everything is happening in this box. And to simulate microgravity, we use neutral buoyancy to inject the polymers into liquid in a similar way that Eitan did in space. The very last thing I want to leave you with is something that hasn't been published before, but Eitan actually, thanks to the delay, the bad weather conditions at the landing site that we're so happy with, Eitan got a chance to run another experiment, which we call the scientific educational experiment. We wanted to show kids that you can use very simple physics and create some very interesting science and engineering in space. And this is Eitan creating now a large lens. This is now a 30-centimeter lens out of water in space. This was actually joint work between Eitan and Mike L.A. You'll see them both here. And he's injecting water. This is drinking water onto this large frame. It was very challenging. We were cheering him from home. This is Matthias Maurer, the German ESA astronaut who just happened to be around, right? Who came to peek. This is the mission, the Rakia mission patch. Money shot. So the camera taken to the side, showing the shape of the water lens. You see? Oh, here you see Mark approaching and demonstrating that as he's changing the distance to the focal point, he's becoming from inverted to magnified. And Eitan is now removing some of the bubbles. These dots you see around are bubbles were introduced during the injection. He's making the lens also a little thinner. And here's again the side view. The lens is now much clearer. Smiling through the lens, you can see the smile in his eyes. You can really see how magnificent this is. Just water in space creating a lens. And the final step, Eitan showed he was actually cleaning the lens. He was removing liquid, but you can see the change in Focal Point demonstrated we can create dynamic lenses in space by injecting or aspirating liquid. We can change the focal point so future telescopes might stay liquid in space. With that, I want to thank everyone who contributed to this project, and thank you, Eitan, thank you, Rakia, thank you for showing that really no dream is beyond reach, and we have a lot of new dreams as a result of this. Thank you.
Carrying out a space mission is a complex and challenging operation, as most of you know, since you took part in it and sat in the control room in preparation for our mission. A mission control center was set up in Tel Aviv, where the scientific teams could monitor Eitan's conducting their experiments live. But none of them would have been possible without NASA Marshall Space Flight Center in Huntsville, Alabama. The payload and the Integration Center helped us design the experiments to their full potential, wrote the long and detailed crew procedures, and led the communication with the team during that mission. Chrissy Canarday, the AX-1 mission payload lead at NASA Marshall Space Flight Center, was involved in each and every experiment conducted in the mission, which make her the best person to summarize it. Ladies and gentlemen, Chrissy Canarday, please.
Hello, everyone. I am from Huntsville, Alabama. Marshall Space Flight Center is the location that we are at, and I'm part of the Payload Mission Operation Division. So we integrate all of the science on ISS at the moment. All of our national lab or NASA science goes through us. We integrate, we operate, we train, we take all of the visions of the scientists or the students, and we make it reality. We get it in a procedure and a planning model that the crew can just click, open, and execute. Hopefully that simply. That's our goal. We also train the crew whenever we can on the science. We also train our cadre, our flight controllers, as you can see in this picture here. And we train each one of us, and we sit and operate console 24/7 to execute all of the operations. Currently, I am the private astronaut mission payload lead. This is officially a position now. It was not before. It was one of our lessons learned. As these private astronaut missions come through, each one is dynamic, each one is unique, and we need someone to kind of integrate and coordinate and make sure our team knows what they're doing, knows what the intricacies are, knows what the crew needs while they're on orbit. I've also been a PACOM for 11 years. So the PACOM position is our payload communications manager. This is the second best job in the world. First is obviously astronaut, but second is talking to the astronauts. So we communicate, we're your crew advocate. We're the ones listening to you guys to see if you're tired, to see if this procedure is not working, anything we can do to make life better for you guys while you're up there. One of my favorite parts of this mission was how much hands-on science I got to experience. We plan missions 6 months at a time with 6 crew. It is packed full of science. We don't usually have time to meet with the scientists, to see their goals, their visions. Everything is quick, we're hurrying up, everyone has a budget, everyone has a contract. We're trying to get all the science done as much as possible in a short time as possible. But for this mission, it was a little different. Crew members brought their own science, they were invested, they knew the scientists. This piece of it was amazing for us. I'm not gonna say I have favorites, but maybe my favorite was the bottom left one. We called it the Fluid Space Optics Experiment for this mission. And it is not just because they let me play with the hardware and make a lens, but the excitement of this team and the personal connection this team had to one of the astronauts was something that I haven't experienced before in my 11 years. So it was awesome to be able to be a part of that. And when this science experiment comes to fruition on both fronts with the space telescopes and with the lower economic lenses, I will be so proud to say that I had a small part of this, just a small part, but it's so cool to be able to touch and feel the science. So for this mission, since we had more time to train the crew on their science because it was important to them and special to them, we got to go down from Marshall and go participate in some of the crew training. This bottom right picture, you can see this is where we trained Eitan on the experiment. This is our life science glove box. It's the one we have on site in Houston to give you sort of an idea on how it feels. And I'm sure Eitan will tell you it was similar, but not the same. Just watching the video of the gloves and the inflation and the air inside and how difficult it is to maneuver And then, thankfully, it was me in his ear, not Moran, saying, all the air bubbles, Eitan, get all the air bubbles out, make it perfect. I'm just teasing. But it's the best we can do to simulate it, but it just kind of gives the astronaut a feel for why we're gonna put things where we're gonna put them. Your arm is gonna bump it if this is right here. So it's a very valuable time for us to train the crew. For this particular mission, we also had the procedure as ready as we thought we could. So while it gives the astronaut a chance to learn and understand what he is going to be doing, it gives us a chance to validate the procedure, find out what works, see what doesn't work, see what steps needs to be changed. I wish we could do that on every single one of our experiments. Usually the scientist team does it themselves and then we just operate it. But this time we had our ops team there, we had the science team there, and we all really worked together for this payload. And that is something that we don't get to do very often. So this mission was full of science. I saw some of my favorite payloads on the previous slides, and I just have to make a note about the antenna. I remember when they brought that proposal to us, and they said it's gonna be a 2 to 3 foot antenna and it can't be touched or bumped with 11 people on space station. I said, okay, sure, it's gonna be great. How many times did we call you guys to say, hey, somebody bumped the antenna, can you take more pictures? I think we all stopped counting, but I was very, very proud to see the results that came from that. That was pretty much all of their science. They woke up, took pictures of lightning, they worked all day on cell science in the life science glove box. These guys were going from morning until noon, or morning till night, just working hard all day. I remember telling Mark in one of his training classes that you guys are gonna be so busy, you're gonna need to schedule time to look out the window. So he did, but it was still science. It was still a payload. It still wasn't like, hey, go out, look out the window and have a good time. They were very busy, and it was amazing how much science they accomplished in such a short time. I think it was a little over 3 years ago when we first heard PAM mission, private astronaut missions, and we kind of all freaked out and thought, how can we do this? This would be really cool. Can we do this? Is this even possible? And then if it does work, can I go? Can my kids go to space? Like, how well is this really gonna go? So the opportunities that these missions are gonna create would and could open up was amazing to think about. In those earlier years, they also told us no payloads on that first private astronaut mission. So we were like, sweet, we get a first row seat to just watching. And then very quickly that changed, and we were very busy the whole mission, just as busy as you guys were. But from those 3 years to watching you guys float through the hatch, that was like the finish line of a marathon. It was the best moment. I know I had goosebumps and tears in my eyes, probably not like you guys did, but it was so cool to see how hard all of our different teams and companies worked for that moment. So I'm sure it felt like crossing the finish line of a marathon, but it was just beginning. You guys were about to have the busiest few weeks of your life, and we were there to help you the best we could. One of the things my PACOM team does over a 6-month mission is we get to know the crew. We get to know their tone of voice, we get to know kind of the looks on their faces, if they forget the cameras on, just some hand motions, some characteristics. For your mission, it was so short, we tried really hard to hear that in your voice, to know if you were tired or having a bad day, or if you were really sick of us asking for that camera shot one more time. But it taught us how important that really is. In that short of a mission, we need to be able to understand your needs and what you guys need to get that science done as fast as possible. So my team stretched and grew, and we learned a ton from your mission. We learned ways to improve how we are gonna operate and support the next cruise. So all the future crews have you guys to thank. And I'm sorry we didn't get there as quickly for you guys, but the future crews will learn immensely from what we learned from you guys. One of the things we learned that was probably should have been more obvious was how many acronyms we have. I feel like we have a new one every single day, and you're gonna compound that with you flying to station the first time, being in a foreign place, and we just keep throwing these acronyms at you like we expect you to know them. And then the other one that is my favorite is labeling. Every tool has to have a different name. You can't have 40 syringes that are slightly different and call them the same, so it is very important. But some of them don't make much sense. Like, for instance, our high torque locker tool. And I just asked you to go find that. And then after a few minutes of nothing happening, I was like, it's the long screwdriver. Got it. So we now know to say that all together and kind of package that call as one. So thank you for learning our growing curves, growing pains with us. But I know X2 and all the other private missions will thank you guys for this. So we definitely enjoyed this. This was a once-in-a-lifetime experience for you, and we got a front row seat. So we got to experience this whole mission with you guys, right with you guys, doing the science. And one of our favorite things experiencing this with you was the handset when it was hands-free, and Larry had his hands in the glove box. All your pep talks were for us too. I know you probably didn't know it at the time, but we could hear everything. Focus, you can do this. We are thinking the exact same thing on the grounds. And it was great. It was great because we all just sat right there like, you're right, we got it, we can do it. And we loved hearing the stories. Like even when you're getting tired towards the end of the day, telling stories about when you used to cast and how precise it had to be. But it got me thinking, I'm wondering if when you were doing that years and years ago, if you ever thought those skills would be needed in space, if you ever thought you'd be using those skills in space. Like, what a cool thing. Like, we just got a front row seat to the coolest week of your life. So, we don't get to experience that very often. I love that we got to experience that with you guys, but the best part is that we get to experience it at Marshall and Houston many more times. So, I thank you guys very much for letting us be part of your mission and being part of the first private astronaut mission and teaching us how to do this better, how to open up space for everyone, how to keep these missions going. When Larry came through the hatch, no, I don't think anyone could have said it better. We're here to experience this, but we understand the responsibility to do it right. I think we all did it right. I think we showed the world that we did a great job and we're gonna continue doing this, and I know I'm excited that I get to keep doing this. So, thank you guys, and we appreciate everything you did for payloads and science and space for everyone.
Thank you, Chrissy. Chrissy is going to be here for the rest of the week, so anyone would like to discuss further experiments with her, you can set it up with Melody, and you're more than welcome. We'll have some time for fun, apart from that. I'm happy to invite, we'll talk about the Rakia mission that was about suggesting a new and complete model for human special space flights to create the opportunity to include individuals and communities who've been traditionally sidelined in human narratives around space, while also maintaining the central role of scientists and researchers. And now we're happy to present to you, for the first time ever, one specific and unique artwork that was created during AX1 time in the ISS. According to Melody, this activity was harder to coordinate more than some of the science one. I'm happy to invite Dr. Yanai Oyster to present Earth Signal Universe-Wide, a joint work with Nimrod Astrakhan. Please.
Thank you. Hello. Thanks for having me. It's an honor. So this wasn't fully discussed here on the stage, but there was also an art mission in space. So I'm going to be talking about the art mission in space. I'm also going to be talking about some conversations we had on Earth with Eitan. So a while ago, maybe would have been 2 years ago, myself and Eitan and another friend and colleague were discussing a matter with Eitan. And then we kind of coincidentally heard that Eitan was going to space and that Eitan had contacted a whole bunch of Israeli scientists and technologists and a whole bunch of people from leading institutions in Israel. And so we said to him, well, you do know that art is a rigorous form of science. And of course, we just said it, but then he said, well, yes, of course, which would have been unexpected from anyone else, but not from you. And it was a pleasure. So we kind of started the conversation going, and then it turned out that a whole bunch of us had kind of been in contact with Eitan, and so it was agreed that there would be an art mission in space. So of course the question in space is, well, how do you make art, right? Because you can't carry anything, you can't take anything up, it's very complicated. And then you can't really make things over there, right? There's no space, there's no facilities. And you can maybe make things which are very small. Now we wanted to make something which was big and grand, so to speak. So we thought, well, there's a plethora of electromagnetic possibilities up there in space. And so that's the conversation that we started conducting, and this is what I'm going to show you. The solar system, in it, the ISS. Now, how does one actually make an artwork in space without anything to hold or touch? Well, it becomes very easy if one wants to make an artwork which is invisible. which is, again, perhaps the time to acknowledge the fact that the persons here on this stage before me were scientists. They all had amazing imagery, right? Very attractive imagery, very profound, very beautiful. Our imagery isn't. We're visual artists. We don't need amazing imagery. What we're going to show you is conceptual art, right? And so, after kind of a great number of conversations, both with Melody and with Hadass, and of course with Eitan, and a whole bunch of people who found it very peculiar, very difficult to understand, well, what are these guys about, right? So they're artists, and they want to take something from the Dead Sea, which is obviously the lowest or deepest point on the crust of the earth in the Syro-African Gorge, and then they want to take that thing, or a sensor reading, that was the thing that we took, they want to take it and then they want to do something with it up there. Well, why? Why should anybody want to do anything with sensor readings provided by the Geological Survey of Israel up in space? Well, because those sensor readings, when transmitted up to the International Space Station and from the ISS transmitted universe-wide, those represent a abstract, conceptual, artistic way of remodeling the heartbeat of Earth, which is what we did, which is what Eitan did for us for about 90 minutes. Now, it proved to be very, very difficult to actually transmit heartbeats in space. When heartbeats are of such magnitude, and when coordination becomes very, very complicated, and then Melody can confirm that it was very, very complicated, we thought it'd be very easy to relay a sensor reading up to the ISS, and then from the ISS to another satellite, and then harness the entire NASA infrastructure for our service. Obviously, that proved to be a bit more difficult. So what ended up happening actually is that we were granted access to the interplanetary internet. And so such a thing actually does exist. We didn't know it at the time. We didn't know it entering the mission. And then the interplanetary internet allowed us to actually devise a web art or net art piece, which contrary to most net art pieces, I'm not going to talk about this so much, but contrary to net art pieces, this one was designated for the use and pleasure of only one person outside of Earth, being Eitan Stiber. And so basically we built an interface for Eitan, and this interface was accessible from his tablet. And then up there, Eitan with the tablet was able to actually push a button, and then the button activated the transmission. We were, of course, rigged or connected to the sensor on the Dead Sea. And then from then, that moment on, for about 90 minutes, a transmission expanded, transmission from the ISS around Earth and outside the solar system. The transmission expanded. We thought of it, we still think of it, we still describe it as an invisible sculpture, one which nobody ever saw or nobody will ever see. This is as close as we can get to actually seeing or looking or touching it, but it is indeed an artwork. It is a conceptual artwork, and it was a conceptual artwork facilitated with the aid of Eitan. Over there, we have a website, Earth Signal Universe-Wide. Bits from the simulation have been projected downstairs, but I urge you to actually log into the website where you can find a whole bunch of other examples and trivia, bits of information about art in space, conceptual art, and art in Israel. Thank you.
Thank you, Yanai. We'll take a 30 minutes break. You have refreshments downstairs, but make sure to be back because we're going to talk about medical experiments and the cooperation with Axiom. We have great news for you, so come back. Enjoy. Please take your seats. Thank you so much for joining us again. In the second part of the conference, we will be discussing the medical aspects of manned space travel, the challenges, the innovations, the science behind it all. Shir, you with us? Yes, the person that will lead this section is Dr. Shir Stiba, pediatric resident at Sheba Medical Center, an AX-1 mission specialist, backup astronaut who had been in Houston, Texas for the NASA, SpaceX, and payload training. During this period, Shir also completed the Principles of Aviation and Space Medicine course at UTMB University. Shir, the floor is yours.
So good evening, everyone. I am very excited that this evening is happening. We have been talking about it, I think, before the mission flew up to the space station, and having all of you guys here makes me so happy. So thank you very much for being here. I want to share with you that as a pediatrician, resident in Sheba Hospital, on a daily basis, I do encounter problems we still do not know how to solve. So having a number of clinical experiments or human experiments on this mission was very significant for me. We will start this part with, now I'll take my text. We have Dr. Michelle Hong Chan. Michelle is a dear friend and an MD and a PharmD. She received her Doctor of Pharmacy at the University of Texas and her Doctor of Medicine at the University of Texas Health Science Center McGovern Medical School. She completed a residency in emergency medicine at Baylor College of Medicine and a second residency in aerospace medicine at the University of Texas Medical Branch in Galveston, Texas. She is currently a mission flight surgeon with Axiom Space. Michelle. So I had the privilege to be a patient of Michelle as an astro in training, because part of what you do is prepare us for the flight. So it wasn't only you guys that got her. And I think maybe to start this panel, it would be good if you could give us a short intro of what does it mean to be a flight surgeon?
So that's actually sometimes a very difficult question to answer, what it means to be a flight surgeon. First and foremost, it means taking care of the astronauts that go to space. And that starts from the second that they decide that they want to go to space. Part of that's with the selection process. Part of that is certifying them medically to make sure that they're as healthy as possible. And then we work hard to do, kind of treat them like professional athletes so that they can be optimized in their health so that they're at their best performance shape when they're on mission. Then of course we take care of them during mission. And as they come back, there's also readaptation. But that's only a small part, actually, of what I do as a flight surgeon, which is kind of amazing to me. So there's also operational medicine that we do in terms of manning console and helping understanding some of the parts that as it relates to how the human interacts with the mission itself and making sure the mission is successful.
I want to interrupt just and say that manning console is a short phrase of a big thing, of actually being the contact on Earth for the astronauts and being their person, their go-to person when they feel bad, when they feel sad, or whenever they do need help and can't help themselves. Imagine yourself going on a long trip to an unknown place, having someone to navigate you between all the mess and knowing how to make you feel better and feel comfortable to fulfill all you heard about that was built for the short time, so many things to do. That's very meaningful.
I'm glad you feel that way. Sometimes I forget that you were one of my patients. Yeah, so there's the operational aspect. We also get to provide some technical support and expertise to the engineers, and that's something that's a bit of a learning curve for me. I don't have an engineering background, and learning how to speak their language and answer their questions that make them happy, but still help them understand how important it is to take care of the human, not that they don't understand that, is something really special. And the last part that I really enjoy is also getting to do some of the research aspect, much like we're seeing during this conference, and I think throughout this week, hearing about the science and how it really advances what we can do in the future. Those are very exciting parts of what I get to do.
Thank you. You said at the beginning that a big part is getting them prepared as special athletes to be on their best show on time. I think this is especially important in missions like these and for the future of space, where you actually, as a physician, in opposed to the NASA missions, you just get a given team. They were awesome, 4 rock stars, super, but still a given team that you need to actually represent in front of international boards, that they are qualified and that they won't risk the whole operation that's in the space station. So I think that's a very big part of this being a first mission of a kind. How was that?
Yeah, that's a really good point. So traditionally, we think of aerospace medicine as taking these really well-selected, extremely healthy, extremely fit people and taking them into space. And that's held true so far. But now, as we're commercializing low Earth orbit and trying to expand space for everybody, we realize that that's not going to be the regular population that goes up there, and we don't want that to be the population, right? We want to make this as accessible as getting on a commercial airplane. And that being said, people are going to have some sort of medical problems, whether it's something as simple as high blood pressure or high cholesterol, to maybe some things that are more severe. And we might not think it as severe down on Earth, but could have some major consequences in space. So something as simple as, we think of it simple now as diabetes, might not be that simple to manage in space. So screening and selection is very important. I think something that's unique now, especially in these private astronaut missions, is we have the opportunity to say yes to everybody. We don't want to disqualify anybody from flight. And so part of it is understanding their medical background and doing a very extensive screening process, not to say no, but so that we understand and can quantify what the risks are so we can prepare better and make sure that we have medications and plans in place to help protect the human and make sure that the mission is successful.
Yeah, absolutely. This is, you know, you were talking about planning, taking part in a space mission, doesn't matter if it's medical or not, planning A and plan B, and having a plan C and a plan D for every scenario. And I was wondering, on AX1, did you have any unexpected events that made you change your plans or even surprised you guys?
Well, not to get into much of the medical privacy of any of our crew.
Without names.
However, you know, what surprised me actually was that we had all these plans, and the reason we have these plans in place is really something called Murphy's Law. The more you overplan, hopefully the less likely you have to use any of it. And I would say that that held very true for the AX1 crew. They did phenomenally well, not only with adaptation into space, but also adaptation when they came back. So much so that I think Larry was doing yoga poses within a day or two of coming back, and even though I was trying to stop him from himself, it really wasn't necessary. I think what surprised me was some of the other aspects that you don't always think about as a doctor and someone, and it's a point to what we do operationally, is at one point in time, while they were doing experiments, it was realized that one of the payloads didn't have the correct needle that they thought was supposed to be in there. And so it's not very often that medicine can, or a doctor can help save a little bit of science, but we were able to find something within our medical kit that would substitute and serve so we could keep going. And so that was an exciting part that was unexpected that I did not plan for in the mission.
Amazing. I think also the fact, like you said, about diabetes, the fact that people with a wider range will fly will also expand very much the science that we can produce from these flights. thinking a little bit forward about the future of space medicine, do you have a vision? Because I feel like it's going to be totally different.
So there's probably like a 5-year vision, a 10-year vision, a 20-year vision, a 100-year vision of what can happen in space. I think if we look long term, I think that there's opportunities for unique medical clinics in space that could offer certain rehabilitation or therapies that you just could not get on Earth. And then something that excites me that I think is actually closer to becoming a reality is potentially the 3D printing of organs. So these tissues are so fragile, it's not something that we can do on Earth in 1G, but in 0 gravity or microgravity, there is a possibility of printing these fragile tissues. And then imagining that you're taking it from the individual's own stem cells, and then using that to create the organ, we could potentially even eliminate the idea of organ rejection or graft versus host disease. And that's something that I can't imagine how much that would change the world.
Amen to that. I think a big part of maybe the pioneering of space medicine was telemedicine, long time before COVID was here and we could see our physician through the TV and show him our son's ear or other problems. And actually we have a researcher here in the crowd, Dr. Hila Ben-Pazi, that sent with us a device. Hila is a neurologist, and she sent a device to help better telemedicine for I think it will be very relevant for the long duration flights, to have more and more health data about the astronauts. Hila, I don't see where you are with this. Sunny light. Hi, good evening.
Good evening, Hila, founder and CEO of Stroke Alert. What we do, we monitor, detect, and alert stroke here on Earth. So stroke is the most disabling factor today on Earth. When we did the space mission, what we found that even during a short flight, there was some flow changes. Now, with longer duration, I'm going to ask you, what will be the implications of such monitoring and telemedicine through space?
That's a tough question. Well, I think there's a couple parts to that. One is, like I mentioned earlier, we're going to see people that are going to either have a higher propensity for stroke, or just by sending more people out there for a longer period of time, sadly enough, it's bound to happen. It might not happen in the next year or two. It might not happen the next decade, but we'll see something like that. And to have the capability to monitor early on, and maybe stroke is one of those things, and for any of you guys familiar with some of the acronyms, at least in the US, we use the acronym FAST. And it just shows that time is brain. And so the faster you recognize it, the faster you do something about it, the more you can help the patient and potentially save a mission, definitely save the patient from debilitating effects long term. So being able to monitor that in real time, or even in a rapid manner, and deploying medications would be invaluable. In the short term, it could help us decide what type of medications we want to spend. And then one more aspect about that is we're talking about going from 1G to 0G on these missions, and that changes the blood flow. But what happens when you go to the moon and you're changing the gravity once again, and it's not quite 1G, but it's not microgravity, and then you go again further maybe to Mars? That could have ramifications on maybe the risk of stroke in individuals.
Thank you. So thank you very much for this talk. I can talk with you for hours, and I'm so happy you're here for this week.
Likewise.
And I wish you a good Israeli Space Week. That will be it for our conversation this evening.
Thank you. Thank you for having me.
To continue this part of the evening, I would like to invite some more speakers. And I'll take my pages again. So I would like to invite to the stage 5 talented representatives of a few of our researches. We had many more, and this night is way too short for everything I want to hear. But we'll start with what we have. I would like to invite David Burstein from CRISPR Experiment. David is a senior lecturer in the Shmuni School of Biomedicine and Cancer Research at the Faculty of Life Science at the Tel Aviv University. Second guest will be Dr. Gal Antman, who is leading the experiment called the Eye in Space. Gal is an ophthalmology resident at Rabin Medical Center. At the same time, he's a postdoc fellow in eye disease and innovation in ophthalmology at Mount Sinai Health System in New York. Our third speaker would be Dr. Harel Baris from the Sheba Arc Space Innovation Center. He's a physician at the ARC, the Innovation Center of Sheba Medical Center, leading the ARC Space Lab. Next guest would be Yair Levy. Yair is a co-founder and CEO of the startup called BrainSpace. BrainSpace, I'll tell a little bit about it, a sentence, please, go on. BrainSpace is on a mission to make brain data accessible for everyone, enabling researchers, companies, and even astronauts to accelerate innovation with accessible, accurate, real-time, reliable brain data and actionable brain insights. And he will explain soon what does that all mean. And last but surely not least, we have Dr. Efrat Baron Harlev. Dr. Efrat will be here as she's the CEO of Schneider Children Medical Center since 2020. She's a medical doctor graduate of the Ben-Gurion University. She completed her pediatric graduate at the Ben-Gurion University, her pediatric residency and pediatric critical care fellowship in Schneider, mastered in public health administration at Harvard University. And on top of all that, she's a leader in accessible pediatric care, not only in the hospital, but also in Israel's outskirts and beyond. Wow, okay. So I'm very happy to have you all here. We have half an hour, and we're going to talk about so many interesting things. I would like just to start with a short scope. If each one of you will take a short round, can say what's your experiment or who are you presenting here, and maybe what was the incentive of your project or your space project.
Okay, I tried. I'm Gal Antman. I'm from Rabin Medical Center, and we did research under the wings of Professor Irit Bachar and Dr. Orly Galor. And what we wanted to accomplish is basically there is a space-associated neuroocular syndrome, which is basically an eye disease that astronauts have after long space flights. And we were lucky enough to use a new imaging device that is out in the market today that hasn't been used. And we thought that the vascular blood flow has a possible contribution to this disease, and we were the first to use it in space, before and after space.
Cool. I'm David from Tel Aviv University. I represent a joint group from Volcani, in the Pines lab and my own lab, and we were working on a project to do genetic diagnostics with a new system. Think about a PCR diagnostic, but as simple as portable as an antigen test. And we're working on it before there was this wonderful opportunity, and we wonder whether we can use it in order to diagnose disease in space. So that was our mission.
Hi, a pleasure to be here. I'm a physician at ARC, the Innovation Center of the Sheba Medical Center, where we envision how to shape the future of health on Earth and beyond. And in our ARC Space Lab, we think and vision ways to harness the opportunities of new space to advance healthcare innovation. And I was fortunate not only to lead the 6 clinical studies of our medical center, but to be the foots on the ground for many of the other investigators. And I had an amazing experience trying to problem solve many of the challenges of actually conducting the studies throughout the mission, either before and after.
Sometimes small tasks like first void after splashdown is impossible, and without having someone there to decide it's going to happen no matter
carry
what,
the
it's
ice
impossible.
packs, and even finding some tubes during tornadoes where Amazon Prime is closed. Tough luck. It was an amazing experience.
Thank you, Ale.
throughout.
So first I would like to say I'm honored to be part of this panel and sharing the brain space perspective on the Rakia mission. And I will elaborate a bit to give you the content. So BrainSpace is the brain data company. And we make neuroscience accessible for everyone and actually everywhere, even in space. And we enable organization companies to collect, analyze, and use brain data to enhance research, product development, and hyper-personalized treatment and services. In this experiment, we work together with the Ben-Gurion University, Owen Shriki Labs. He's here in the audience, I believe. And what the experiment goals were, well, during space missions, astronauts are being monitored for every tissue. They continuously being measured for their heart rate, blood pressure, for body temperature, but there is one tissue which is not measured, it is not monitored, which is the brain. And why is that? Because it's so complicated. You cannot send an MRI machine up to the space. And believe you looked at the travel list, there is no EEG technician there.
No, and putting the EEG with all the glue on your head when you have no shampoo and running water, that's just a big no-no.
And it's take back an hour. So if you're familiar with that, it's a very challenging task, even here on Earth, not to mention up in the International Space Station. And this is where BrainSpace come into play. We provide our brain sensei. It's a brain gear that can be easily, in a few minutes, can do the exam that takes hours on ground. And the goal, of course, is to provide ongoing monitoring along the mission. And we thank the astronaut to participate in that.
Thank you, Yael.
So at Schneider, we say that children are above and beyond. What does it mean? Children are above and beyond any kind of action that we are doing because we want them to be well. Children are above and beyond because they're the future. Children are above and beyond gender, race, politics. They're above and beyond everything. And when we take care of children, we believe that we should not only take care of their disease, but rather look at them as children. So when I first heard on the news about Eitan's flight and about the mission of educating children, I said, educating children above and beyond, Schneider must be there. And so when we decided to send our mission to space, it was obvious that it wasn't going to be just the hospital's mission, but rather the hospital with children. So in a little while, you will be able to hear about this project that we've made about cancer cells in zero gravity, but we did that with the children of the hospital so that we can empower our own patients, so that we can educate them, but also learn from them what does it mean to be a child with cancer, that looking at her own cells or something very familiar to her own cells. So in a second you will hear about that, above and beyond.
Thank you, Efrat. This is a truly inspiring story. And beyond the personal inspiring story, I think each researcher can relate that his dream would be having an enthusiast researcher in his lab that is very interested in the disease, in the mechanism, and also in healing. And I think that this is maybe the best example possible. So we have with us here a lovely girl named Michal Khan. Michal, she recovered from leukemia, and she was treated in Schneider Children's Hospital. Hi, Michal. Michal will tell us a little bit. Beyond what I said, which is a big part, but only part of her story, she took part in her in the high school final project in biology, and she took part in this research for quite a while with Dr. Diti Birger.
And the teacher, Shai, who is also here,
right.
because we have a school at our hospital as well. And just one word about Michal. So she's our patient, she's our student, and she's our pride, because she's the first one who was all three of them, but she's just the first, as this was a first for you, Eitan.
Michal. The mic is not working. Can someone help that?
Thank you so much. Thank you for the warm introduction. It was incredibly healing and emotionally valuable to participate in this experiment in collaboration with Schneider Children's Hospital, which I'm so grateful for, about leukemia, which I had finished treatment for in 2020. And exactly a year later, I had the rare opportunity to join the preparations of an experiment that I later watched being launched to space. The experiment checked how microgravity influenced the mortality rates of leukemia lymphatic stem cells in order to better understand the chemical cell pathways that lead to cell death known as apoptosis. This could potentially assist in creating less toxic cancer treatments and less harmful side effects for chemo patients. I'm very thankful to Rakia mission for this once-in-a-lifetime opportunity.
So really just one more word. I'm an ICU physician, so I understood maybe 3 words of what she just said. But seriously, for us, patient empowerment, because children are so smart, so strong, is part of what we learn from them and then what we teach them. So this is part of the Schneider spirit. And thank you for being able to have that experience with Rakia. Thank you so much.
Thank you, Michal. Thank you, Efrat. I think beyond the educational part and the healing part of this project, it was true science, and real conclusions and real learning can be done from it. So that's a divine combination I wish all experiments could include. Thank you. Okay. We have a high standard. So we will continue. We're jumping to the other side. Dr. Gal Antman, the eye in space. Tell us a little bit. You know what, before you start, I'm sorry I'm interrupting. We have an opportunity to hear a few words about visual changes during spaceflight. That's a problem that has been widely researched, and we still have a lot of questions that are left open, and maybe Gal can help answer some of them. And if I may ask MLA for a little bit of his experience.
Thank you. Well, first of all, I want to both thank and congratulate all of the investigators on the stage. Your contributions to the Rakia mission were obviously very important, and I think we surprised, as Larry said a bit earlier, a lot of people by the importance and the legitimacy, if you will, of the science that we conducted for a private astronaut mission, so thank you for that. So my experience with this, as you described, SANS, space-associated neuroocular syndrome, used to be called something different when we thought it had to do with interocular pressure or intracranial pressure. But it started my previous mission. You know, I was a pilot, so I was farsighted, and I was age 48, so my arms were starting to get a little bit too short. And so I was wearing reading glasses, and I launched on the Soyuz capsule, which is very small, and so the panels, the screens are very close. And so I had a prescription of contact lenses that was sort of extra strong, maybe a half a diopter or more stronger plus, so that I could read the screens as they were close. And the plan was that when I got on board ISS, I would take those out and put on my regular contacts so I could go about my business. And what I found is that when I did that, things were a bit blurry, and ended up flying the entire mission with stronger contact lenses. And this is about the time when we understood that this was an issue. It was never really known at NASA because it generally only affected long duration flights, and we had mostly been flying the shuttle, of course, which are 2 weeks at the most, so we didn't really know much about it. But at this point, people were starting to pay attention. So when I came back, I had a full investigation, and you can maybe describe some of these symptoms I had, but or not symptoms, but diagnosis. I had something called cotton wool spots. I had choroidal folds. I had some edema of the optic nerve. But most importantly, I had a farsighted shift, a hyperoptic shift of about, depending on the eye, a diopter and a half, which for a 7-month mission is probably more than, you know, the rate that your arms get shorter. Anyway, all the other stuff resolved quickly within a week or two, but the vision changes stayed, and I just wear stronger contacts.
Thank you, Mike.
Oh, that's a lot to take in, even for me.
You don't need to interpret all the symptoms.
No, but I think I'll speak about some of what you experienced was in long duration space flights, and actually, because this space flight was much shorter, we wanted to see if we can diagnose or even to use some of the imaging devices that we had on a shorter flight to maybe foresee if they contribute to the long space flights as risk factors. So what we did is basically use the multimodal imaging, and we had, I will speak only on one modality, which is the OCTA. And before talking about the results, I want to thank everybody in my team that took part of it. It's not working. We need another, oh, got it. Okay, so OCT stands for Ocular Coherence Tomography, which is an imaging device of the eye. It pretty much uses, just like ultrasound uses sound, that sound travels, hits the tissue, go back to the device, and then it is being analyzed, and you can see a picture. So here, it's the technology uses light. Light is emitted from the device, hits the eye, comes back to the device, and then we have an image. Now, this device actually, no, we have some technical problems.
Lucky we are not in space now.
Yeah.
Chrissy, we need you.
Okay, so here, I'll just continue pressing the green, hoping something good will happen. So basically, this technology, we take different images only a few milliseconds apart, and every change in the tissue is translated into movement. Okay, no.
Go on without it. You can do it.
I'll just try the other one. Kim. Oh, yeah, the other green, and every change is basically translated into blood flow, okay? And what we have different layers in the retina and the choroid. This is the posterior part of the eye. We have different plexi of vessels, and we can image each and every one of them. So what we did here, this is the imaging of our participant, of Eitan. And on the left, you see the tissue itself. In the middle, together with the engineering college of FECA in Ramat Gan, we were able to do image analysis, and all the yellow dots are basically the movements, which are basically the blood flows. So we compared the pre and post-flight. Here you can see the upper one is the pre and then the post-flight. And the results were that we were able to show a larger thickness of the diameters of the vessels in the choroid. And here you can see another image of, it's called enfas, when you basically look at the deeper structures from above. So the vessels themselves changed, the structure itself, the choroid was thicker. And here we did like a heat map of the choroid and the retina. And on the left is the right eye, and on the other side is the left eye. And this is the retina and the choroid, and we were able to show that there is a difference in the retina of, in the right eye, 8.5% reduction, and in the left eye, 6.5% reduction in the blood flow. And what's more interesting is in the right eye, we had almost 30% reduction in the blood flow, and on the left eye, 11% reduction, and this was all statistically significant.
That's many words that I think we can interpret it as something very significant for a researcher.
Yes.
And for whoever doesn't understand the statistical significance, but I think you actually got very, very accurate data due to very high will of the astronauts to go through long and special tests that haven't been done before at this timing, before and after.
Exactly. And Eitan was extremely patient. We had him for over 5 hours per session, and it wasn't easy, specifically when he got back from space, and it was hard, but we were able, thanks to his much patience, to do everything. And these are the conclusions, and we were, just like you said, it's the first time anybody did imaging of the OCT angiography, and we found some major differences that are worth, this is n equals 1, it's worth continuing researching on more patients, more astronauts in the future.
Well, I think in about 50 years of human spaceflight, there have been more or less 600 people in space, so all researchers have n, like a very small n to rely on, so starting with 1 is a big difference from knowing nothing. Thank you, Gal.
Thank you.
David, Dudu.
Yes.
Dudu took part in the CRISPR experiment, a little bit of some more basic science. You guys started from the call for proposals, as you said. You had something before that was not space related and kept on going from there. How was that?
That was great, but I have to say, as you said, we were clueless about space. So we knew our system very well. We're working on a CRISPR-based system. And CRISPR is used for genome editing. It won the Chemistry Nobel Prize 2 years ago for that. But we had zero experience in space. So for example, at the beginning, we thought of sending it as a dry powder. And then people says, you don't want dry powder in the International Space Station. And even just the experiment, we did like 2 simple experiments, like Eitan had to pipette these little wells. I'm sure you remember them well. And we say, well, these are fairly simple experiments to do, right? And then there was a panel in Tel Aviv that shows all the experiments and what Eitan has to do in each one of them. And then I said, oh, this is more complicated than we thought. But basically what we did is test this CRISPR system that is very sensitive to detect DNA, and we tested a few components, briefly how you amplify the DNA in space, how you detect it, and then we wanted to see how low we can go, how little DNA we can identify. And we had Eitan do it in 2 long sessions in the International Space Station, and a week later, the exact same experiments were done in the US with the same plates that were sent to the US to make sure they were under the same conditions by 2 very experienced PhDs. And I don't have a slide, but if I would show you the results, you wouldn't be able to see which was Eitan and which was the others. So this was amazing results for us. And
I think even though you planned complicated, yes, a more complicated experiment for Eitan as opposed to the kits that you are planning on using in clinical use?
Oh, for sure. I mean, I said it's a very simple technology, but Eitan didn't know anything simpler because we didn't even kit. We just let him test all the different stages. And since we had only one shot, he did many repeats of each one of the experiment. And the bottom line with the detection was that we were able to identify 8 molecules of DNA within 100 microliters. So it was really very sensitive.
Amazing. I think you also shared with me before the uses for this technology, the CRISPR technology, which is not only medical, it's only, you shared with me and I found it fascinating, when exporting agriculture or good fruit from Israel, to be sent out, they are stopped before shipped out and tested for bacteria and such, and that delays the amazing fruit from coming so fresh abroad. And with your kits, things will change, hopefully.
Yeah, so this is a project that we did with the Volcan Institute with Gur Pines is here, and this is actually he's leading that project. And he did part of what the Volcan Institute do is try to help in these fronts of also exporting goods. And he does this test especially for pests, so fly pests that the Europeans are really anxious about not getting there for good reasons.
Right.
Yeah, and indeed it can save a lot of goods for farmers in Israel, and that's.
So it's actually a technology that is significant on Earth already and has a meaningful impact here, and it has been proved now that it can work in space, and especially for long mission flights, it can make a change too.
Exactly. We're thinking about the health of the astronaut, and you say crops, so we're also thinking when we grow potatoes on Mars, like we saw in The Martian, so you also want to know if they have any viruses, and this
and
would
probably
be...
they will have some special viruses we never heard about
I sure
at some
hope
point.
not.
I think also in the astronauts' busy schedule, which was full of work, I really have a vivid memory of the video when Eitan, it's like in a Zen mode, pouring in each well with the pipette. You say pipette?
Yeah.
One drop in each one, and he was like totally calm. Was that the situation when he did it too?
Not here. We were very anxious. It was also reporting each time, so it was Alpha 11 to Bravo 11, Alpha 11 to Alpha 12 to Bravo 12. And one time it was like the wrong one, and we were all, now we didn't have direct connection with Eitan, but one was the one and immediately cut it up, but we had like a small heart attack. And at the end of the experiment, I should note that Eitan let our plate float in the air.
Because it's beautiful.
It was beautiful, very photogenic. We were all having a heart attack back in Israel. My PhD student was, that's my PhD going on. What is he doing? But as I said, the results were amazing, and the photos were great too, so.
Good job.
Thanks for that.
I didn't see him tonight, but I wasn't here very early, but I think it is a good opportunity to say that Dr. Eliran Chemo was very involved in the CRISPR experiment, and he was very significant in all the Rakia mission, and I want to give him a big thank you, even though he's not here on the stage. Is he here? Okay, Arel, from the Sheba Arc Space Innovation Center. And I'm from the Sheba Hospital too, as I said, from the pediatric ward. And I think there was something very unique from this medical center to send 6 experiments with Rakia, because Sheba Medical Center has an ARC space lab inside the hospital and facilitating a lot of small projects that can fall very easily with all the dynamic changes that spaceflight has, was the biggest advantage of a big center, hosting all these small projects, small but significant, as we said before. So why? Why would a hospital do such a thing, and what's the added value of doing?
What a great question. I'm not sure I'll be able to answer, but Our vision in ARC is to shape the future of health, to provide better care for everybody, basically. And it means a lot of effort and blood, sweat, and tears, which I was blessed and honored to accompany during the execution of the clinical studies of the Rakia mission. So the ARC Space Lab visions is to harness the potential of new space to advance healthcare innovation in general. And while the contribution of space to medicine, to healthcare in general is tremendous, we are very excited about three promises and benefits of space that resonate our mission. And I won't be able, unfortunately, to speak about all of our 6 clinical studies for obvious reasons, but I'll try to give examples for each promise and how we were able to demonstrate it. So in our opinion, or in our eyes, the first value is to demonstrate, play, and develop tools and methods to deliver care from afar. The crewed space missions are an amazing playground to provide comprehensive, preventive, focused care from afar in a way that, unfortunately, we are not able to provide for each and every of you. And as example for that, a very cool device that is being developed in Tel Aviv University and at Sheba Medical Center can execute blood tests non-invasively in real time. The VI device that the inventors of are sitting among you guys can spare the needle, spare the lab, and provide maybe the most critical task that we are using in our clinical routines, daily routines, even without resources. The promise of such technologies to facilitate and support deep space exploration missions is incredible, but not least the sparing of the needle for our day-to-day tests and ability to deliver care without a nearby expensive lab equipment is amazing for Earth and health equity as well. So that's one. The second
Absolutely,
thing,
I want one for my ward, please.
Of course. The ability to refer to the microgravity environment as a resource is igniting our minds, and we are one of the first groups who are looking at the effect of microgravity as a feature and not as a bug, and we tested the ways to treat Alzheimer's in space. And just like Michelle mentioned, it's holding amazing opportunities. And last but not least, but the ability to collaborate with incredible researchers and groups from here and internationally is an amazing opportunity that we are so glad to have, and what an exciting mission.
You said it very shortly, but I want to just take a few more seconds on that topic. You said using microgravity as a resource. And when we were talking before, you talked about the Dead Sea, for example. People from all over the world would come to the Dead Sea if they have psoriasis for their skin care and helping them resolve or making the situation better. And I think dreaming big and dreaming far is really looking at microgravity as a potential place for treatment, and not only just to explore something and to see if that astronauts like it or if it can help a specific situation, but actually have a safe place for specific diseases.
I will add an accessible way.
One day.
Not only one day, hopefully.
Thank you, Ariel. Yair. Yair Levy from BrainSpace, as I said, co-founder and CEO, that part of their experiment was actually conducted from the lowest place on the crust on Earth, where they had a researcher in the Dead Sea, a vacation at the time, who was online with the ISS with his experiment being conducted.
So, as we see today, failures can happen even here on ground. And I would like to touch base 2 points. First, Gal, you mentioned the patience of the astronauts. I would like to add curiosity. And on the second round of the experiments, we had about 12. Eitan decided to do something different. And he flipped over during the cognitive test. And lucky for his curiosity, of course, in zero gravity, there's no impact of doing that upside down. It's not like in cartoons that you're falling. And we added another proof for our experiment. We proved that a device can be accessible for brain monitoring, but also doing that upside down. So thank you, Eitan, for your curiosity and of course, for the dedication of the entire team. Thank you very much. And coming back to the story about that, so yes, failures happened, and we had a communication failure with the headset on the 3rd day, and we have another 5 days to run the experiment, and it was horrible. We spent 9 months, and again, we are a startup company with 11 people, fully dedicated for the mission. We managed to pass all the 9 stages of hell in order to reach the successful launch, and even to pass the upside down experiment of Eitan. And then on the 3rd day, a failure happened, and my team leader, Amir, who is sitting here, who was the responsible guy for the technology, is on vacation. And he's in the lowest place on Earth. And of course, luckily, and you know the end, luckily, he managed to communicate with the International Space Station, actually from the bottom of Earth up to the stars on the highest point where people were at that point. We managed to solve the problem, and of course, to comply with a very successful experiment. So thank you very much, guys.
Thank you, Yair. I think your story is quite unique, even though we do have a few partners that are companies, but having a startup company that obviously calculates very well its resources, its time, its human resources, and you didn't start as a space company, am I right? And diving into this world and taking this whole startup company, which is not huge, right? You're 11 people, and shifting it all for this project. Was it worth the round? Time will tell.
So we proved 3 points. First and most, we proved that brain sensei can work in any environment, and it's accessible device. And coming back to Michelle's presentation, accessibility is one of the key factors in medicine in space. Second, once space travel will become common, and astronauts will need to have a monitoring device along the travel, BrainSense has already proved that it has a validated solution. And last but not least, my team, my dedicated team, proved themselves. There is no dream beyond reach.
Another amen. That's another device I'm ordering for the pediatric ward. No more glue. Hello. Ifat, do you think you will continue? I think maybe something in Rakia project, AX1 project, mission, and Schneider is using the curiosity it enlightens in eyes of people. And I was wondering if, as a hospital also, if you think you will continue some sort of collaboration.
Yeah, so I think that when we talk about innovation in pediatrics and in children, when you look at the healthcare world, about 90% of investments are going to the adult world. So when we talk about innovation at Schneider's, we know that a spot like this should turn in a very small angle towards the children. And that is because all of us were once children. And many children that did not survive 30 or 40 years ago, today, when we are in the new technologies, are young, healthy adults, just like Michal. So, yes, of course, we need to look at pediatric care, not only because it's a very large part of population around the world, and especially in Israel, but because our responsibility at Schneider's is not just taking care of the children of today that are ill, but making sure that the healthy children of today become the healthy adults of tomorrow. And for that reason, we need to research more, to do a lot more of prevention, detection, and treatment of the children of today. Definitely, this is what we're going to do, and this is what we're doing today when we talk about innovation in pediatric care.
Amazing, thank you. I feel like we need to continue this at my place because our time is done and I have so many more questions. I want to thank you all for coming and for having long conversations before this panel and sharing your thoughts with all this audience. So thank you.
Thank you. Thank you.
Here it works? Okay. So one last thing. We got a special request, a very touching one, from one of our partners in Rakia. We have here Trish, a Trish representative. Dorit, please come. Trish is a Translation Research Institute for Space Health, is an American space health resource institute that works with NASA to support scientific research and technologies that can keep astronauts healthy during spaceflight. The Trish director, Dorit Donoviel, is here and would like to present the crew of the Axiom 1 team with tokens of appreciation for performing the Trish-sponsored research on their flight.
Thank you, Shir, and thank you for the participants and Dorit. Thank you. Thank you for the gesture. The initiative behind the AX-1 mission belongs, of course, to Axiom Space. Axiom is one of the leading companies in the world in accessible human mission space flights and are working on the first commercial space station. As Eitan said in his opening remarks, Rakia mission is setting off for new adventures, and as in AX-1, we need good partners with us, and I'm happy to announce a new collaboration between Rakia mission and Axiom Space, a collaboration that will be dedicated and is dedicated to promoting Israeli activities on board the ISS, lowering the existing barriers and opening access to space for industry and academia. Following our vision that there is no dream beyond reach, we believe that this partnership will continue and the vast impact achieved on AX-1 and inspire many more dreamers, educators, artists, and researchers. Please welcome Mr. Christian Mander, Executive Vice President in Space Solutions, Axiom Space, please.
right up here. All right, thank you for thank you for having me, and thank you for involving me in this mission. I think I first want to recognize Rakia for what it is, and it is, among many things, it is among demonstrating family to me in Israel, because I got the pleasure of meeting all of the Stibe family, and it's been personally wonderful to meet all of you and be a part of this. And it's exciting to be able to be here today to talk about what we did with this Rakia mission on AX1 and what we're going to do with Rakia in the future. So I'm going to focus today about how Rakia and Axiom are creating new opportunities for Israel in space. And I want you to think about today as a new beginning for, and think of the AX1 mission as a pilot project for what we can do in the future. Now I'm going to go find the clicker real quick because I don't have it. Okay. So this picture is really memorable for me because it is the launch of the crew and the beginning. It's the beginning of the mission, which represented a huge amount of work that we, Axiom, did to get that mission off the ground, and all of you did to get this mission together. I remember as an anecdotal story when we first met Eitan, and Eitan asked the Ramon Foundation to come in and help put this mission together, and I was talking with Ron and with Melody and with Eliran, and they told me the size of the project that they wanted to accomplish, and I said, no, I really think this dream is too big. And it was really a challenge at first to figure out how we were going to fit all of the science that you got to do into this mission. And at the end, I think we did fit most of it, but the point I'm making is that it was an amazing collaboration between the Stibe family, the Ramon Foundation, and the Israeli Space Agency that really enabled this project. And it was something that we transformed in Axiom into believers in what we could do. And I think we're really proud of what we have accomplished with all of you today. Dr. Levy mentioned going through the 9 levels of hell to get these projects to orbit. And let me tell you, if you were a scientist that had to get your project ready to go to orbit on this mission in such a short time frame, it was a big leap for everyone. It was a big leap for Axiom as a growing company. It was a big leap for NASA to swallow that many experiments that fast in a 10-day mission. But everyone, including the agency, really stepped up to the challenge. And Chrissy talked to you about all the learnings that they got out of it and all the things that we learned how to do better together. And AX1 for us wasn't just about Rakia, it was about creating lessons for us, teaching us lessons about how we were going to operate our space station in the future. So I'm going to talk to you a little bit about that as we go forward here, and how we're going to do an Axiom station and what we're going to be able to do with it. So we do more. This is just a reminder of all the places that we were with training the crew and all the work that they did to get to it. Ready to fly, and then arrival on space station. And the best part about what we're doing with Rakia today is that because this is just, as I said, a pathfinder to what we're going to be able to do tomorrow. So as a company, our vision has always been a thriving home in space that benefits every human everywhere. And the everywhere there is super important because it talks about the piece of work that means about putting hundreds of people, even thousands of people living and working in space, but it also means bringing the benefits of space back down to Earth. Dr. Barris talked about the value of microgravity, and that's really what Axiom is about. And so we're really focused on not only putting all of those people into space, but using it to improve life on Earth. And we're starting by building the world's first commercial space station. So we're going to do this in 3 phases. You're familiar with, obviously, the phase 1. We're in this phase right now with private astronaut missions and research and development on the ISS. This AX1 mission was an amazing pathfinder, amazing example of what we can do with even just short missions to the space station. The second phase involves building the Axiom station at the International Space Station. We have been awarded the right to build our space station off the front of the International Space Station. The first piece of that space station should arrive sometime in late 2025. And the missions that we do leading up to that in phase one with these private astronaut missions are really pathfinders to a greater opportunity that a space station, new commercial space station creates. And then ultimately, when the ISS is ready to be retired, hopefully we have extracted as much science out of it as possible, we'll become a free flyer and operate as a commercial space station, continuing to provide services both to the countries that are using the International Space Station today, but really it's more about providing services to all of the countries that are not part of the International Space Station. And that brings us to why we're partnered carefully with Rakia mission at this point, because we really want to open the aperture to all of the countries that have space ambitions and all of the elements, countries, academia, schools, and foundations in those countries that want a chance to do something in space as well. Our mission partners on AX-1 were diverse. I wanted to show you this just because it shows how international this flight was on AX-1, with institutions from the US and Canada and Israel, and really from a number of different countries. And we didn't even get a chance to talk about the science that Larry Connor and Mark Pathy brought to the table. All of it very important research that is answering questions about what it means to live and work in space. Mark got to do some really cool stuff. I wanted to show a couple pictures. I thought there were going to be more pictures of Eitan today, so I only put Mark and Larry in here. But I wanted to show a picture of Mark using a holoportation device where he actually brought people into the space station with him in this augmented reality space, and he actually, ultimately what we're going to do is be able to bring the crew member back to the ground as well. And so you can imagine that interaction can become very important on longer duration missions, especially into the moon or Mars. Technology worked pretty well, and considering what we went through to get that all connected down to the ground, I'm glad it went well. This experiment was very important too. This was Larry doing stem cell work for the Mayo Clinic. And we were looking at a number of different aspects. This facility of all facilities, this life science glove box on the space station, was supercharged in overtime in terms of its use during the mission. But what's important about it is the questions that we're answering about what we can do. The young lady talking about her experience with leukemia, she may not know, but there were other projects on this flight that addressed different aspects of leukemia. And we are learning some interesting things about how to diagnose and treat that just from the very work that we've done on AX-1. So the work that Larry and the rest of the crew did to do this, though tedious maybe in terms of its implementation, was important in terms of its discovery. So what's the next phase for Axiom and for the partners that we have with Axiom? We're building the space station kind of in a stepwise fashion. The first module will attach to the space station. It's a habitat module that'll allow us to do both science and house crew. The second module is another habitat module, which will bring the crew number up to about 8 crew, and that's 8 in addition to what was already on the ISS today, along with additional experimentation space. And then the third piece of the space station will become a research and manufacturing module where we can really start utilizing the space station in its full capacity to do not just the continued research like we did on AX-1, but really start looking at in-space manufacturing applications as well. The final piece that will come up is what we call our power tower, and it really provides the thermal heat rejection capacity and the power generation capacity to really be an independent platform. This isn't just a paper project. These pictures are nearly a year old at this point, but they represent actual pieces of the space station being built right now. The first module is nearly complete in terms of its welding in Thales Alenia with our partner in Turin, and we'll be arriving in Houston this summer for our start of assembly and integration. Rather than tell you about it, I wanted to give you a little bit of a tour through our virtual reality, which is a tool that we use heavily at Axiom to really start figuring out how we're going to build the different human factors features for the space station. Mike, I don't know if you did this or not, but yeah. But this is our habitat module. We're going through here. Behind these panels are crew quarters and environmental control systems, along with what will be galley and toilet and shower and those kinds of things. You can see the radial ports here where there is a place to attach additional modules and certainly visiting vehicles when they come up. The crew member who's translating through the module is going to work his way into the second habitat. Again, a mirror image of the first one we went through. So in addition to the sleeping quarters that you see that are in the space station, you also have a place for payloads to do work. Everything stows away behind these panels. The crew member, as they translate through here, is looking down into the research and manufacturing module, up into the power tower, and you can see an EVA suit or a spacewalk suit stowed up there, and then finally translates down into what we call the Earth Observatory. Now, if you thought lightning research in the cupola was cool, wait till you do it here. And this is going to be a really unparalleled opportunity to take view of the Earth and take view of the limb of the Earth. And it really gives you some perspective on how big this module will be. And it will be there for, obviously for fun, but a lot more for science and observation. So we come to the point where we talk about what we're doing together. And I think I've got some notes from this because it is important to talk about kind of what we are going to do. So Israel, through Axiom Space's relationship with Rakia, is going to build economic and scientific opportunity for the country of Israel and the companies in their space ecosystem. Axiom Space's newly signed agreement with Rakia is going to power the transformation of low Earth orbit into a global space marketplace. The point here is we're really trying to create access beyond the partners of the International Space Station and bring the whole of countries in to access space. This agreement's really a fusion of critical capabilities. It brings all the knowledge here in the room and all of the knowledge in the country together. That brings that expertise together with the services that Axiom provides to provide new opportunities in space. And it's an agreement that's really based on collaboration, where we're going to share a lot of data that help. We will take the advancements that we know of that are being done in the space profile today, share them with Israel, bring them back, and let Israel add building blocks to all that, so together we can build a future together. So I think the focus here, and I think hopefully Eitan can share more about it, is that we're really committed to working together to build a better life on Earth, and that really speaks to the mission of our company. So thank you. So let's talk about the opportunities that this partnership starts to create. Research is super important, but it's not just about research. It's not just the only opportunity that this creates. A commercial space station creates opportunities for government agencies, including the Israeli Space Agency. It creates new opportunities for private astronauts, whether they be private citizens like Eitan, or perhaps even a worker from a company that needs to go to conduct the research that needs to be done. Researchers and manufacturers get to use this for all sorts of different things, even just some of the things on the right. I'm not going to read them all to you. But great examples of some of the pathfinders that we already did on AX1 today are Moran's lenses and some of the things that we did with the tech development with NSLCom, and that just creates a lot of opportunities for that. We can power space exploration opportunities. We can create, as we talked today about some of the art that was done on work, we create opportunities for media, for filmmakers, and for STEM educators. And we create opportunities for both commercial and defense enterprise to use space in a more meaningful way. And ultimately, we're going to be able to use it as a platform to stage different missions directly from space. All of that opportunity is created as we build the space station, and now all of that opportunity is available to Israel as we go forward. So, in summary, and I'm just going to go back to this, Axiom Space is really trying to build history, and we want to do that with as many partners as possible. We're really building the human experience in space with the opportunities that we create to fly people to orbit. And we really build prosperity through opportunity, and that opportunity really is the access to microgravity and opening up that opportunity to as many people and as many entities as possible. So in closing, we hope that as many of you continue to want to come build history with us, and I appreciate the opportunity to be here today and be a part of this. Thank you.
Thank you, Christian. It sounds interesting and exciting, the new collaboration. We're getting close to the end of this conference, and for some closing words, I'd like to invite to the stage the chairperson of Rakia's scientific committee, Inbal Kreis, please.
Thank you. Thank you, Christian. It is very important, the collaboration agreement. Impact. What is impact? What is the definition of the word impact? The dictionary describes impact as having a significant or major effect. Rakia mission impact is highly significant. During this afternoon, we all heard a few excellent examples which highlighted this mission's impact. One of the prime examples of this included the introduction of challenges in the development in advanced manufacturing capabilities in space, such as creating an application of optical components and lenses within the space environment. This effort achieved grant from NASA's Innovative Advanced Concept Program, which support future missions technologies. Another excellent example with a future potential impact is the COTS capsule experiment, which facilitates the design, which protect off-the-shelf space-approved electronics under space radiation exposure. And there is also the Nissan experiment that is aimed to improving high bandwidth communication from space, which required to all future missions to be performed operational in near and also in deep space. And the list is quite long. From my personal experience during my day job as the head of innovation in the System, Missile and Space Division in Israel's space industry, I am simultaneously running several accelerating programs dealing with open and hybrid aerospace innovation challenges. From my personal experience, Rakia technological mission to the ISS set and defined a unique technological accelerating mode, faster, larger, and on top level global scale. And the collaboration with Axiom Space is highly important. Rakia mission will continue to serve as a launch pad for international partnerships and collaborations dealing with diverse space exploration research areas. The growing interest in groundbreaking research areas and multidisciplinary approaches to space science continues to expand rapidly. This is the essence of our future missions, where we will continue to offer innovative and multidisciplinary insights to space exploration in order to contribute to a better and healthier world. There are no limits to what we can create and what we can build together. Looking forward to our next inspirational chapter. Rakia, there is no dream that is beyond our reach. Thank you.
Thank you, Inbal. Thank you all for being here tonight. Mike, Larry, Eitan, and Mark. And special thanks to you, the research teams that participated in the Rakia mission. We had the time only for a handful of experiments to present today, but we're eager to hear more outcomes and the contribution of all of you. You're more than welcome to join us downstairs for drinks and light dinner. And remember, there is no dream beyond reach. Thank you. Good night.